Today we are going to review understanding factors, multiples, prime, and composite numbers. So there are several vocabulary terms that you are going to need to know for this section of math. So the vocabulary here is one of the most important things. The concepts aren't too complicated, but you really need to know what the words mean in order for this to make sense. So we're going to start out with factors. A factor is a number that is multiplied by another factor to make a product. So for example, if we are looking at a standard multiplication algorithm here, the first one, our multiplicand, is a factor. Our second, the multiplier, is also a factor. So I remember a great fun teacher explained it to me saying that factors are like factories, they produce products. So these together make the product. So in this case, you can see that we have two factors and that when multiplied together, we get the product. Now, a multiple is a number that can be divided by another number without a remainder. So, for example, 15, 20, or any other multiple of 5. So a multiple, you'll see that relates back to factors, right? So we know what the factors are that we can multiply 5 over and over and over again, but then we also see those multiples of 5, and when we divide, we can find the factor of 5, or we can find the multiple of 5. So those two words go together, factors and multiples. Prime number is the next term. A prime number can be divided evenly only by 1 in itself, and it must be a whole number greater than 1. So for example, 5 can only be divided evenly by 1 or 5, so it is a prime number. But 6 can be divided evenly by 1, 2, 3, and 6, so it is not a prime number. It is a composite number. So note, 2 is the only even prime number. It's kind of its own special thing in there. It happens to be a factor of every other even number, which means that all other even numbers are going to be composite because they are divisible by 2. So 2 is its own special unique thing. It's the only even prime number. A composite number is a whole number that can be divided evenly by numbers other than 1 or itself. So for example, 9 can be evenly divided by 3 as well as 1 and 9. So 9 is a composite number, but 7 cannot be evenly divided except for one big group or 7 little tiny groups of 1. So it is not a composite number, it is a prime number. You will often see this used with things like factor trees. I have seen a couple places that go sideways and call them factor fireworks, but honestly, factor tree is probably the one that you're going to see the most often. So a factor tree is a tool that breaks down any number into its prime factors. A certain number's prime factorization is the list of prime numbers or prime factors that you would multiply together to get a certain number. So if you'll see here, we have an example of the number 48. 48 then was broken into two groups of 24. 2 is already prime, can't break that one down anymore. So we'll keep that group of 2, but then we can break down 24 into two groups of 12. We go down again, we can break that 12 into two groups of 6, go back down another level, and now we have gotten everything broken down into their prime factors. So you get the number 48 by taking 2 times 2 times 2 times 2 times 3. 48 is the only number with that specific set of prime factors. So those are the only number that can make is 48. Every other number is going to have its own special set of prime factors. They're sort of like the special ingredients. And again, they can only make that one number. So each number is very special in that it can be broken down into a set of prime factors that are going to be unique to that number. So let's work a little bit with prime and composite numbers. Here we have problem number 1. The area of a rectangular garden is 7 square yards. So list all the possible whole number dimensions that the garden can have. Well, the only option here for whole numbers is 1 yard times 7 yards. There is no other option that would be within whole numbers. So the area of the rectangular garden that is 7 square yards must be 1 times 7. Problem 2, we have another garden, but this one is 8 square yards. In this case, you could have one that is 1 times 8, long and skinny, or you could have one that is 2 times 4, which is a little bit short and wider. Both of those will equal 8, 1 times 8 or 2 times 4. So here you can see that there are 2 solutions. If there's more than just 1 times the number, that makes it composite. So the whole number dimensions of 1, 2, 4, and 8 of the rectangular gardens in problem 2 are the factors of the number 8. Problem number 1, the number 7 only has 2 factors. The number 7 is prime. So in problem number 2 above, the number 8 has 4 factors. The number 8 is composite. So those are some important definitions there. A prime number has only 2 factors, one in itself. A composite number has more than just those 2 factors. And then the number 1 is kind of its own unique thing. It's only made up of 1 times 1. So it's just such a unique number that it's neither prime nor composite. It's just kind of its own separate thing. So when the area of a rectangle is a prime number, there's only one set of possible dimensions for that rectangle, only one option. When the area of a rectangle is a composite number, there are 2 or more sets of possible dimensions for that rectangle. Each set of dimensions is a pair of factors. So to determine if a number is prime or composite, follow these steps. Find all the factors of the number. If there's only 2 factors, one in itself, then it's prime. If the number has any more than that at all, then it is composite. And it cannot be prime and composite at the same time. So let's look at some examples here. Is the number 2 prime or composite? Well, the factors of 2 are only 1 and 2, so 2 is prime, and it's the only even prime number. Then example 2, is the number 9 prime or composite? Well, we can get 1 times 9 or 3 times 3, so yes, 9 is composite. We have determined if a single number is prime or composite. So let's look at a range of numbers to see if they are prime or composite. Please note that each range of numbers given in examples 3, 4, and 5 below are inclusive. So found all the prime numbers between 2 and 9. The factors of 2, well, it's only 1 times 2, so 2 is prime. Factors of 3, well, it's only 1 and 3, so 3 is prime. Factors of 4, something exciting happens here. You can break down the number 4 into 2 groups of 2. That makes it composite. 5, there's no way to evenly divide this except 1 times 5. But 6, you can have 2 groups of 3, or you could have 3 groups of 2. 6 is composite. 7, oh yeah, 7's prime, only 1 times 7. But 8 can be divided. You could get 4 or 2 groups of 4 or 4 groups of 2, so that one is composite. Also, it's live long and prosper. Factors of 9, you could divide 9 into 3 groups of 3, so 9 is composite. Now you can continue this, and for the purposes of this video, I'm not going to walk through every one of them, but you will start seeing that once you get past the number 10, there are a lot fewer prime numbers because you're going to start getting into multiples of each of those. Multiples of the number 2, multiples of the number 3, multiples of the number 5, of 7. So those prime numbers are going to be factors of so many other numbers that there really aren't that many prime numbers once you get past the first few. So again, for the purposes of this video, I'm not going to do all of those, but you could do that on your own as you can see the pattern. So here we get down to number 6. Is the number 31 prime or composite? Explain your answer using full sentences. You know how much I love full sentences. The number 31 is prime because its only factors are 1 and itself. You could also say 31 is a prime number. This is because the number 31 has only 2 factors, 1 and 31. Or here's another example of how you could explain it. I divided the number 31 by all the numbers between 1 and 31 and found no factors other than 1 and 31. Therefore, 31 is prime. There are many possible ways to explain the solution to this problem. These are just 3 possible explanations. So in summary, a prime number has only 2 factors, 1 and itself. A composite number has anything other than just those 2. It just takes 1 more factor pair beyond that in order for it to become composite. All right, so this is an introduction on prime factors, or prime numbers, composite numbers, factors, and multiples. They're, again, specific vocabulary terms that have very specific meanings, and you will want to know the difference between all of them. So take a minute to review and do a little bit of prime factorization yourself so that you can get more comfortable with how numbers can be broken down into their factors, and then how those factors can be multiplied together to find their multiples. So enjoy exploring the world of math.